Hey, Professor. So for my video example, I'm going to go with my notes I've taken here on the left side of the screen, and then kind of come back to Desmos over here on this side as we talk through this. But I went ahead and chose this formula here, 2x to the third minus 30x squared plus 54x minus 9. So the first thing that we're going to do with this polynomial is to find the first derivative, which we could use the power rule to do that and pull down 3 to the -9 goes away with the 0, and the x for 54 just becomes 54. So our first derivative turns into 6x squared minus 60x plus 54. And so from there, to find the critical points, we should do some factoring and make everything equal to 0. So this formula works out quite nice because you could extract 6 from everything, giving us 6 with x squared minus 10x plus 9, and then factor even further to get 6x minus 1, x minus 9. These work out to come up with this to factor into that. But if we make these equal to 0, then we end up with our critical points being at x equals 1 and x equals 9. So to determine increasing or decreasing, put a little plot here. And if we have 1 and 9, the next thing to do, I went ahead and found or used 3 different numbers on this range here to see if we had positive or negative values. And so inserting these, plugging these into the function for the first derivative, if we use -1, for example, we're going to end up with, here's how that equation works out. But we end up with positive 120. Okay, so right here, if we did 5, remembering that our critical points in 1 and 9, so if we did 5, then we end up first derivative of function of 5. This all comes out to -96. So we have a decreasing here. And then if we did 10, on the other side of 9, we end up with positive 54. So that demonstrates that as we look at this graph, we can see an increase from, according to this, -infinity to 1, critical point 1, and then also increasing from 9 to positive infinity. And then there should be a decrease from x equals 1 and x equals 9. Looking at the graph, this is a bit of a kind of sharp graph, but if I zoom out, we could see that there is the increasing, so negative infinity this way up until, if I look at that point there, then we have number 1, and then the decrease going in this direction here from this way. So this point right here in the x should be 9, and it is. And then we see our graph continuing to increase up into positive infinity that direction. Next thing we're going to do is look at the second derivative and determine what that is. So let's pull out from the first one, pull the 2 down, also pull 1 down, which that just comes out to be what it is there, -60. And the second derivative ends up being 12x minus 60. So we could factor the 12 out of that, giving us 12 parentheses x minus 5 put that equal to 0. And we end up with a point of inflection at positive 5. So next we'll do concave test to see where things are concave down and up. We can obviously see them in the graph, but let's confirm that here as well. So put our little range of numbers here. And if we put 5 here in the middle, and let's just go 2 down in this direction, 2 up in this direction. So let's try 3, positive 3 and positive 7 and put those into the second derivative function here. So second derivative of 3 ends up being 36 minus 60, as you see, negative 24. So that confirms that we have a negative value below 5. And then if we try 7, we end up with positive 24. So then we end up with over here. And that does tell us that our point of inflection is 5. So if we look over, well, here, let's just back up real quick. Concavity being in a downward angle, or downward, I guess, position, if we're going to call it that. But that it would be from negative infinity to positive 5. And then that's where that inflection happens, where the curve starts to go upwards instead, where we have 5 to positive infinity. And if we look at this, it's a little hard to tell, but let's go along this line. We know that's at 1. And so things start to curve down this way. And 5 should be somewhere about right there-ish. I'll try to zoom out and show the best I can. So right where I have my cursor is the point of inflection, and it does end up making out that at this point right here is where we end up having, yeah, it's not really working well when I zoom out, but I think you understand what I'm trying to say is that at this point right here, we have, if we look up on the graph, that would be the concave down position. And then if we went to the right, we would have the concave up position. More things to talk about here with the limit test. This is pretty straightforward. Looking at a limit of x to infinity, because we have a cube root here, even with the coefficient of 2 in front, whatever we put there is going to give us positive values. So positive infinity, and we can confirm that here by, we know that the graph goes out to infinity. Negative values, a negative cube root is going to give us a negative number, of course, times the coefficient, then we're going to get a negative infinity. So absolutely, I think the graph kind of speaks for itself there. And then the last thing we want to talk about was the relative max and mins. So pulled this this little range chart again from what we did earlier, but this time we already know where the positive and negative, the increasing, decreasing values should be from this first derivative. So just to test the if things are concave or not, we're looking for the horizontal line, horizontal tangent line rather. So if we took the critical points 1 and 9 and put them into the second derivative, like this, in this case, second derivative of 1, we end up having a negative value, negative 48. And then if we did second derivative of 9, we end up with a positive 48. So that does confirm that if we did put tangent lines, you know, they would go up in this direction, and then they would be horizontal. The first one at positive 1, and then the second one at, and then also another one at, if we continued that forward, I guess it's not a second one, but if we did a tangent line at 9, you would have another horizontal line, indicating the relative maximum and minimum. And we know that the maximum is actually 1, because that's the taller part of the graph, and then the minimum being positive 9, because that's the lowest part of the graph, aside from negative infinity. All right, I think that confirms everything. So that's it for me. Thanks.